Welcome to another video. This is laboratory experiment number 4, routing protocol and basic LAN configuration. In a network system, it is very important to communicate even in longer distances. As we already knew, a connection inside the building is a LAN connection in which we can communicate any end device inside the premises. The problem is how we can communicate outside of the premise. The solution is to connect various LANs. The intermediary device responsible for this is the router, in which it selects the best path by locating the IP address even in different networks. The knowledge in topology, IP addressing, and LAN design is very essential to understand this experiment. The objectives is at the end of this activity, we are expected to be able to configure a router configuration or connection, construct a LAN to LAN connection, design a simple network topology depending on the application. Okay, so we are going to start the experiment. You just open the Cisco Packet Tracer. Okay, we are going to connect a hub and 3 PCs. It's going to select a generic one here. Go to end devices, PC0, PC1, and PC2. Okay, this would serve as our LAN A. Okay. You could automatically select the appropriate cable type by dragging the cursor in the network component box, and under the connection stack we could select the smart connection. Okay, so we are going to connect this, but before that we are going to assign IP addresses to our PCs. Go to config, and then we go to fast Ethernet 0. So the IP address is 192.168.1.1, and then a generic 255.255.255.0 for our subnet mask. Again, on the PC2, go to fast Ethernet 0, and then we assign an IP address 192.168.1.2. Okay. And on our last PC, put config fast Ethernet, go to 192.168.1.3. We're now going to connect the PCs to the hub. Okay. And then we are going to choose our router. On our experiment, we are going to select 1841 router, which will serve as router A for LAN A. In the network component box, we click on the router. Okay, we click on router 0, go to config mode. Okay, we could now change the name of the router to Cisco 1. And the display name, we'll change it to Cisco 1. The host name, Cisco _1. Note that the equivalent iOS commands is entered in the lower portion of the window. It's good to take note of this, so we are going to learn this method next. Now we are going to assign a IP address on a fast Ethernet 0 over 0. Okay. Go to 192.168.1.10. Go with same subnet mask 255.255.255.0, and then we enable port. Select this on. Notice the iOS commands here, no shutdown, and see that the interface of fast Ethernet 0 over 0 has been changed and it's up. Okay. We could on our experiment, we are going to try and connect this Cisco router with another router here using a DCE serial. So we could as on this experiment it says a copy of Cisco 1, we could go to edit, hit copy, paste it here, then we could change the host name to copy of Cisco 1. Okay, we are going to try and connect this. So with a DCE serial connection. So if you would notice that there is no port, there's no module installed here. This is where we are going to install our DCE serial connection. So we select a WIC 2T. Oh, the power's on. Remember to turn this off first. Okay. We zoom in. There is your serial link. Serial 0. And we are going to do that also on our remember to turn it back on our router, copy of our router here. So we go to physical, turn it off, we select the module WIC 2T. Notice that there is a description of the module here. Turn it back on. Okay, so we are going to connect our router using a DCE connection. Here we select serial 0-0.0 and connect it to the same serial port. Okay, and then we are going to connect our LAN to our Cisco 1 router. Okay, then we are going to assign an IP address. Fast Ethernet here. 192.168 1.10 11.5550. Okay, we are now going to set an IP address for our serial connections. So since we are only, remember that the routers separate two networks. So this one is a network, this one is a network. This two is a network. Okay, so we go to config, we go to serial, and then we assign an IP address. So it's 192.168.2.1, and we go to since there's only two networks here, go to 252. Okay, go to our next router here, serial 192.168. That 2.2 and 252 on on. Okay, the indication that it is successfully connected is there should be two green lights blinking on the output side of Cisco underscore our Cisco 1 router, and the input side of copy of Cisco 1. See, there's blinking lights here. So this concludes our experiment. Thank you. So questions. What is the importance of routing? The router has become the primary control point in the increasing complex network environment, holding responsibility for service quality and security, monitoring efficiency, and other attributes that allow networks to add value. If you control the router, you control the network. This is true in a static network, of course, but even more so in today's typical case of rapidly evolving enterprise, where migration to fully IP-based services is underway. Question 2. Why do we need a router? Why not use a switch or a hub? Routers are completely different devices. Where a hub or switch is concerned with transmitting frames, a router's job, as its name applies, is to route packets to other networks until that packet ultimately reaches its destination. One of the key features of a packet is that not only that it contains data, but the destination address of where it's going. Question 3. Why is it important that each PC has different IP address? What will happen if we will use the same IP address? Two computers can safely have the same IP address in certain cases. In most cases, if those two computers are on the same local network, it breaks the connectivity for one or both of them. Internet protocols work by sending small, individually addressed messages. Each message can be routed differently. Connecting to a website usually involves at least tens of these messages, and often thousands. If you only get half the message while the other computer with your IP address gets the other half, nothing will work. In almost all cases that I know of, well-designed protocols simply won't work. Duplicate addresses don't make one machine controllable by the other. They just break the network connectivity. Question 4. What can you conclude from this activity? That routing is the hub around which all of IP connectivity revolves. At the simplest level, routing establishes basic inter-network communications, implements an addressing structure that uniquely identifies each device, and organizes individual devices into a hierarchical network structure. Traditionally, routers have also served as the media adapters that have connected remote offices to headquarters via a WAN. The most recent trend, though, is to see the routers as the integration platforms for a wide variety of network enhancements, such as security, policy, and services that extend the capabilities of IP to support telephony, video, legacy service integration. These are for old devices and other application over a converged network. So this concludes our video. Thank you.